In this video, we are going to revise the fourth chapter of the NCERT 9th class, structure of an atom. So we will be only discussing and revising the important point. Okay, let's discuss about in general, the electron is represented as E negative and a proton as a P positive. The mass of the proton is taken as 1 unit and its charge as +1. The mass of the electron is considered to be negligible and its charge is minus. So mass of electron is negligible in comparison to the mass of the proton and mass of the neutron. So while calculating the atomic mass, we only consider the mass of the proton and mass of the neutron. Proton plus neutron equal to atomic mass. Since the mass of the electron is almost like 1/5000 times the mass of this, so we don't take the mass of the electrons. It's negligible. Then different scientists over the history tried to explain the structure of the atom, and the structure of atom was evolving and improving over the time. And first we discuss about the Dalton atomic theory. Dalton was the first guy who told some about the atom, although it has been told in ancient Greeks and ancient India, but modern atomic structures evolved from the Dalton theory. The Dalton atomic theory says the atom is indivisible but cannot be divided and indestructible, so cannot be destroyed. And J.J. Thomson was the first one to propose a model of a structure of atom. So it just Dalton only say the matter atom is the word atom means A plus tom. To means cut down, and A means it is a negative thing. So atom means something which cannot be cut down. So this is the atom word means. And J.J. Thomson was the first one to propose the model for the structure of an atom. So let's discuss about what Thomson said. Thomson proposed a model of an atom similar to that of Christmas pudding. Okay, like in Christmas pudding, suppose a Thomson model of atom, suppose we have a pumpkin in which the seeds of the pumpkin are randomly distributed inside it. Thomson proposed an atom consists of positively charged pair and electrons are embedded in it. The negative and positive charge are equal in magnitude, so the atom as a whole is electrically neutral. So see, so negative charge contains electron, and negative and positive charge are unequal in magnitude, so that the atom is electrically neutral. Thomas model explained that atoms are electrically neutral. Who was Thomson? J.D. Thomson. He was awarded with the Nobel Prize in Physics in 1906 for his works for the discovery of the electron. So electron were discovered by J.J. Thomson. Now, after J.J. Thomson, the model evolved and a new model was proposed by the Rutherford. And what Rutherford did? Rutherford did some experiment. Let's discuss this. Rutherford designed an experiment for this. In this experiment, fast-moving alpha particles were made to fall on a thin gold foil. This gold foil was about 100 atom thing. You know, gold is the only material which can be malleable into 1 atom thick sheet. So this the used gold foil by the Rutherford was a 1000 atom thick. Alpha particles are doubly charged helium ions. They have a mass of 4U atomic unit. The fast moving alpha particle have considerable amount of energy. So alpha particle is just He. He plus, not H, it He, helium plus. So see, helium is atomic number 2, so it has 2 electron in its orbiting around it. So suppose if 2 electrons are gone, that means the atoms become positive, because 2, it was a neutral first, so 2 electron went out of the atom, and it only the proton becomes. So He, the alpha particle is alpha particle has 2 neutron and 2 proton, no electron, no electron is there. So what it did in experiment is concluded herein. See, you can see that some of the like alpha particles are going straight. These are the gold atoms. Some are reflecting, and one of them is reflected 180 degree back. Most of the fast moving alpha particle passes straight through the gold foils, and some alpha particle deflected by the gold foil with a small angles. Surprisingly, 1 out of every 12,000 particles appeared to rebound. So on the basis of this, he proposed an atomic model, and Rutherford concluded the most of the space inside the atom is empty because most of the alpha particle passes through the gold foil without getting deflected. Second is, a few particles were deflected from their path, indicating the positive charge of an atom occupies very little space. See, deflection means alpha particle is a positive particle, it has a positive charge, and and it deflected from the very few particles, are deflected from their path, indicating that the positive charge of an atom occupies very little space. A very small fraction of alpha particle were deflected by 180 degree, indicating that all the positive charge and mass of the gold atom was concentrated in a very small volume within the atom. So this was the important findings. From the data, he also calculated that the radius of the nucleus is about 10 to the power 5 times less than the radius of the atom. The report put forward the nuclear model of the atom, which had the following features. There is a positively charged center in the atom called nucleus. Nearly all the mass of the atom is reside in the nucleus. See, positively charged center is called nucleus, and second thing is nearly all the mass of an atom resides in the nucleus. We know both are true. The electron revolves around the nucleus in a circular path. The size of the nucleus is very small compared to the size of the atom. Yeah, very small means it is like 10 to the power 5 times smaller. There are also some drawbacks of this model. What are these? Revolution of the electron in a circular path is not accepted to be stable. Any particle in a circular orbit would undergo acceleration. During acceleration, a charged particle would radiate energy. Thus, revolving electron would lose energy and finally fall into nucleus. So, but it does not fall into nucleus, so that means this model could not explain this. So it was saying that this was suppose the electron is revolving, this is a nucleus, so electron may finally revolve, it loses energy and finally will collapse, fall into the nucleus. This could be the drawback. Now the next model is about Bohr's model. Again, a Bohr scientist, Neil Bohr, proposed a model based on its drawback. This was a drawback about how the electrons orbiting. The Bohr model mostly focus on the orbits. So Bohr put forward the following postulate about the model of an atom. only certain special orbits is known as discrete orbits of an electron are allowed inside the atom. While revolving in discrete orbits, the electron do not radiate energy. So it was supposed in a like Rutherford model, the electron while circulating the nucleus will accelerate and will radiate energy. Now Bohr's model is explaining that discrete orbit, if electron is revolving in a discrete orbit, it do not radiate energy. Okay, and who was the Niels Bohr? Niels Bohr was born in Copenhagen, appointed professor of the physics at Copenhagen, Nobel Prize for his work on structure of the atom in 1922. These orbits or cells is called energy levels, and they named it energy level. Energy level of an atom are shown is there are different energy levels. Nucleus is there, then first energy level N1, K cell, L cell, K, L, M, N. These are the cells, these are the energy levels. When the electrons revolve in these energy levels, they do not radiate any energy. Okay, these orbit cells represented by letter K, L, M, N and number 1, 2, 3, 4. Now talks about the neutron. In 1932, J. Chadwick discovered another subatomic particle which had no charge, a mass nearly equal to the proton. It was named the neutron. Okay, neutrons are present in the nucleus of all the atom except hydrogen. So hydrogen doesn't have a nucleus. It has a nucleus, but hydrogen doesn't have neutron. Its nucleus only have a proton. The mass of an atom is therefore given by the sum of the masses of the proton and neutron present in the nucleus. How do electron distributed in the different cell? Now, like Bohr's model explain about the electrons, like electrons evolve in a specified cell, and now like discuss about these cells, how the electrons evolve in these cells. The distribution of electron into the different orbits of an atom suggested by the Neil Bohr and Bury. See the following rules and there are the following rules. The maximum number of electron present in a cell was given by a formula 2n square, where n is a number of orbit, first orbit, second orbit, third orbit. Okay, number is an energy level index. K cell will be the first, so it will be have 2n square means n to the power n 2. L cell will have 8 and 2 to the power 3 is 9. 9 into 2 18. So M cell has the maximum number of 18 electron and N cell have maximum number of 32 electron. So the maximum number of electron can be accumulated in the outermost orbit is 8. Electron are not accommodated in given cell in a given cell unless the inner cells are filled. So it is necessary the inner cells are completely filled, only then the next cell will start filling. That is the cell are filled in a stepwise manner. So here is a representation, here pictorial representation. The first cell, hydrogen have only 1 electron, so it is in first cell. Helium has a 2 is okay, and there cannot be 3. And so lithium only in first orbit 2 to the power n square. First orbit means only 2, n is here is 1, so only 2 electron can be there in the first orbit. So now lithium has a 3 electron, then third electron should be in a next orbit. Then it goes on. It was observed that the atoms of an element completely filled with 8 electrons in an outermost cell shows little chemical activity. So those electrons which have those atoms which the cells of outermost on which the outermost cell is completely filled shows little chemical activity. That means they will not try to form bonds, try to attach chemically, because they are complete stable, they are in more stable position, so that is why they show little chemical activity. In other words, their combining energy, which is or valency, is zero. So these inert means which are not reacting, not reactive, these inert elements, of these inert elements, the helium atom has a 2 electron in its outermost shell, and all other elements have atom with 8 electron in the outermost shell. Here is another graph where helium has atomic number 1, number of proton 1, so it has a valency is a 1 because it needs 1. So hydrogen atom, so hydrogen atom needs 1 uh, electron to get stable. Helium is completely filled, its orbit, the outermost orbit is completely filled, so it is mostly neutral. It would not, it hardly will show a chemical activity. Okay, and carbon has a 4, it has a 4 valency, and neon is doesn't have any valency, that means it also inert, it will not show a much chemical activity. Atoms would thus react so as to achieve the oaklet. Oaklet means 8 atoms in a 8 electrons in the outermost shell. This was done by sharing or gaining or losing of electrons. They share, they gain, or they lose electron to gain, to reach, to achieve outlet. Why? Because this is the most stable position. Therefore an atom of each element has definite combining capacity is called its valency. Now let's talk about the atomic number and mass number. What is atomic number? Number of proton of an atom is called atomic number. Atomic number is number of proton and it is denoted by Z. Suppose for hydrogen Z equal to 1, that means it has 1 proton. Carbon Z is 6, that means carbon has 6 proton. Mass number, what is a mass number? Mass of an atom is practically due to the proton and neutron. Why practically? Because electron mass is almost negligible and we don't count it. Hence the proton and neutron are called nucleons. And the mass of aluminium is 27 U. It has 13 proton and 14 neutron. Mass is denoted by A. A is a mass, X is for symbol of the element, and Z is for atomic number. Atomic number is a number of proton. So what are isotopes now? Same atomic number but different mass number. So same atomic number, so atom will be same, hydrogen, but mass number will be different. That is why it is, because the neutron number are different. There is no neutron, there is 1 neutron, there is 2 neutrons. Protonium, deuterium, tritium. And suppose carbon, isotope of carbon is carbon. It has like 6 neutron and it has like 8 neutron. Okay, and sorry, this is chlorine, and chlorine also have a 2 isotope. One has a mass 35, another has a 37. So important thing is to remember the chemical properties of isotope are similar to their physical property, but their physical properties are different. Chlorine occurs in nature in 2 isotopic forms with a mass 35U and 37U in the ratio of 3:1. Obviously the question arises, what should we take the mass of the chlorine atom? The average atomic mass of the chlorine atom on the basis of the above data will be 35.5. So it was average taken. It is like 3 units, it is like 1 unit. The average will be 35.5 unit. So the mass of the atom of any natural element is taken as the average mass of all the naturally occurring atoms of that element. Application: since the chemical property of all the isotopes of an element are same, normally we do not concern about taking a mixture, but some isotopes have special properties which find them useful in various fields. Some of them are isotopes of uranium is nuclear energy and nuclear reactor. Isotope of cobalt is used in a treatment of cancer. An isotope of iodine is used in a treatment of glitter. It is a like disease where like there appears a huge like bump in the neck. It was due to the deficiency of iodine. Now what are the isobar? The number of a proton in these atoms are different. Number of proton is different, that means elements are different, but the mass number is same. Okay, both so the total number of nucleons is same in atoms. So that means isobars are those elements, are different elements which have the same number of nucleons, means same atom, same mass number. Okay, this is a summary what we have learned so far. Credit for the discovery of electron goes to J.J. Thomson and proton goes to E. Goldstein. J.J. Thomson proposed electron are embedded in a positive sphere. Okay, and after J.J. Thomson the model evolved and new model was given by the Rutherford. Rutherford's alpha particle scattering experiment led to the discovery of the atomic nucleus. So atomic nucleus was discovered by this alpha particle scattering experiment done by the Rutherford. Rutherford model of an atom proposed that very tiny nucleus is present inside the atom. Electron revolve around the nucleus. The stability of atom could not be explained by this model. Why? Because it could not explain like electrons are if revolving. So electron when it's revolving circular path, it accelerates. When it accelerates, it radiates energy. So ultimately, it should be fallen down to the nucleus. This thing could not be explained by this Rutherford model. Now the Bohr's model explained it. Bohr's model of an atom was more successful. It proposed that electrons are distributed in a different cells. Now Bohr model is saying electrons are distributed in different cells. If the atomic cells are complete, then the atom will be stable and less reactive. J. Chadwick discovered the presence of a neutron in the nucleus of the atom. So these subatomic particles are electron, proton and neutron. Electron are negatively charged, proton are positively charged, and neutron have no charge. The mass of the electron is about 1 upon 200 times the mass of the hydrogen atom. So the mass of the proton and the mass of the neutron is taken as 1 unit each because they have a similar mass. Cells of an atom are designated as KLMN. Valency is a combining capacity of an atom. Okay, this is true. Valency is the combining capacity of an atom. If valency is more, it has a more combining capacity, so it will be more reactive. It will show more chemical activity. If valency is 0 or 1, it will show. If valency is 0, it will hardly show any chemical activity. Atomic number of an element is the same as the number of the protons. So atomic number decided by the number of protons. If number of protons decreases, the atomic number decreases. If number of proton increases, the atomic number also increases. The mass number of an atom is equal to the number of nucleons. Number of nucleons means number of proton and number of nucleons. Proton plus neutron. Isotopes are atom, same element. There should be same element but having a different mass number. So they have a different protons. they have a same proton, but neutrons are different, and that is why the mass number is coming different. Isobars, they have a different atoms but have a same atomic mass. Isobars of atoms having a same mass but having a different atomic number. Elements are defined by the number of protons they possess, so it is also there explained. So this is the end of this exercise, and thanks for watching this video.